In this video, we'll take a look at section 8.1, which is exponential functions. Now, our first objective, we're going to take a look at graphing exponential functions. Now, an exponential function has the form f of x equal to a raised to the x power, where a is the base and a has to be greater than 0, and a cannot equal 1. Now, the general form for these exponential functions, the general graph will look like this right over here. So it continues to grow exponentially as x gets larger and larger. Now, we also have this horizontal line, which is called an asymptote. Now, the graph will never touch that line or cross it, and we'll see why in a second. So let's go ahead and take a look at an example. We have graph f of x equal to 3 raised to the x power. Now, first, let's go ahead and change f of x into a y, so it's something we're a little bit more comfortable with. So we have y is equal to 3 raised to the x power. Let's go ahead and create a table, and then we'll start plugging in some points. Now, the very first point that you want to plug in is whatever is going to make the exponent 0. So if I plug in a 0 for my x, that's going to make my exponent 0. Well, let's figure out what y would be equal to. So I have y is equal to 3 raised to the 0th power. So now anything raised to the 0th power is equal to 1. So I have a point 0, 1. Now let's go ahead and find 4 more points. Let's see what happens when I let x be equal to 1. So I'd have y is equal to 3 raised to the first power. So 3 raised to the first power is equal to 3. So now I have another point. Let's say I pick 2. I get y is equal to 3 raised to the second power, which gives me 9. So now I have another point. And now let's go ahead and pick -1 and -2 as well. So if I plug in a -1, I get y is equal to 3 raised to the negative first power, which gives me 1 over 3. So remember our rules for exponents. If you have a negative exponent, you flip it, take the reciprocal, and change the exponent to be positive. Now let's see what happens when we plug in -2 for our x. We get 3 raised to the negative second power, which gives us 1 over 3 raised to the second power, which is 1 over 9. So now I have these 5 points. Let's go ahead and plot them, and then we can sketch our graph. So we have the point 0, 1, and we have the point 1, 3, we have the point 2, 9, then we have -1, 1/3, so let's approximate it to be about right there. Then we have -2, and then 1 over 9. Now, no matter what we plug in for our x, our y will never be equal to 0. So for example, let's say I plugged in -100 for my x. I'd have y is equal to 3 raised to the -100th power. Well, I use my property for exponents. This would become 1 over 3 raised to the +100th power. So 3 raised to the 100th power, this is a really large number. We'd have 1 divided by a big number, but 1 divided by some big number, it's still not going to be equal to 0. It'll get really, really, really close to 0, but it will not be equal to 0. No matter what you plug in for your x, your y will never be 0. And that's why we have this horizontal asymptote here, because our graph is never going to touch this line. It's never going to touch it or cross it. So when we draw a graph, we're going to draw a line that gets really close to that y equals 0, but doesn't actually touch it or cross it. And we have this graph. Let's take a look at another problem. This time, graph f of x equal to 1/3 raised to the x power. Well, let's go ahead and work this out the same way. We're going to create a table and pick some points. First point, whatever makes the exponent 0. So in this case, if I plug in 0 for my x, I get y is equal to 1/3 raised to the 0th power, which is equal to 1. So anything raised to the 0th power is 1. Now let's plug in 1 and 2 as well. So I get y is equal to 1/3 raised to the 1st power, which gives me 1/3. If I plug in 2, I get 1/3 raised to the 2nd power, which gives me 1/9. Now let's try plugging in -1 and -2 and see what happens. So if I plug in a -1, I get y is equal to 1/3 raised to the -1st power. Well, since my exponent's negative, I flip my fraction, change it to positive. So 3/1 raised to the 1st power is just 3. If I plug in -2, I get 1/3 raised to the -2nd, which gives me 3/1 raised to the 2nd power, which gives me 9. Now once again, no matter what I plug in for my x, my y will never be equal to 0. So let's plot our points. So we have the point 0, 1, -1, 3, -2, 9. Then we have 1, 1/3, and then 2, 1/9. So we still have our asymptote here because our graph is never going to touch that line or cross it. And now let's connect our points with each other. Draw that a little bit better. So we get close to that line but never touch. And now we have our graph. Let's take a look at another graphing problem. So let's go ahead, let's change our f of x to a y. So we have y is equal to 2 raised to the x plus 2. Create our xy table. Now our very first point that we want to choose is whatever is going to make the exponent 0. So I have to figure out what can I plug in for my x right over here in order for me to get 2 to the 0th power. Let me just rewrite that. Okay. So I could plug in -2, and that's going to change my exponent to be 0. So I have y is equal to 2 raised to the -2 plus 2, which gives me 2 raised to the 0th power, which is equal to 1. Now I have 1 point. Let's choose two numbers bigger than -2. So let's say -1 and 0. And then two numbers less than it, let's say -3 and -4. Okay, so let's figure out what our y values would be equal to. So I have y is equal to, so let's start off with -4. So I have 2 raised to the -4 plus 2, which gives me 2 raised to the -2. Well, now I have a negative exponent, so I have to flip it and then change the exponent to be positive. I get 1/4. If I plug in -3, you get 2 raised to the -3 plus 1, which is 2 raised to the -1st power. Simplifying gives me 1/2. If I plug in -1, I get 2 raised to the -1 plus 2. So that gives me 2 raised to the 1st power, which is 2. And if I plug in 0, I get 4 for my y. So let's go ahead and plot these points. So I have -2, 1. That was my main middle point. Then I have -1, 2. And I have 0, 4. Then I have -3, 1/2. -4, 1/4. And I still have the same asymptote right over here. Okay, and now let's connect our points. And now we have our graph. Okay, next problem, same type. We're in the graph f of x equal to 2 raised to the x power of -4. So let's go ahead and change it into a y. We have 2 raised to the x power and then -4. Let's create our xy table. Now remember, first point you always want to choose is whatever is going to make the exponent 0. So in this case, I could plug in a 0 for my x. Okay, I choose two numbers larger than that, two numbers smaller. And now we can figure out our y values for these specific x's. So if I plug in 0 for my x, I get y is equal to 2 raised to the 0th power, then -4. 2 raised to the 0th power is equal to 1. So I have 1 minus 4, which gives me -3. Now if I plug in 1, I get 2 raised to the first power minus 4. So I get 2 minus 4, which gives me negative 2. If I plug in 2, I get 2 raised to the second power, which is 4. 4 minus 4 gives me 0. Now if I plug in negative 1, let's see what happens. I get 2 raised to the negative first and then minus 4. Well, 2 raised to the negative first gives me 1/2. So I have 1/2 minus 4, which gives me negative 3.5. Now if I plug in negative 2, I have y is equal to 2 raised to the negative 2 power minus 4, which gives me 1/4 minus 4, which gives me negative 3.25. Now let's go ahead and plot these points, and we'll sketch our graph. So I have 0, negative 3. I have 1, negative 2. I have 2, 0. Then I have negative 1, negative 3/2. I have negative 2. And then negative, I actually made a mistake right here. There should have been negative 3 3/4. I have negative 2 and negative 3 3/4, which gives me this point. Now our asymptote actually shifted. It actually shifted, see that minus 4 on the end? It actually shifted down 4 units. So this is my new asymptote. My graph will never touch that line or cross it. So let's go ahead, connect the points with each other, and now we have our graph. Okay, so now our next objective, we're going to take a look at applications of exponential functions. Now first we're going to take a look at the compound interest formula. So if a principal P has been invested at an interest rate R, compounded n times per year, in t years it will grow an amount A given by A is equal to P times 1 plus R over n raised to the n times t. Now P, this is like the amount of money you invest or the amount of money that you're borrowing. Now what it means by compound interest is the interest that you collect is reinvested into the amount. Let's take a look at an example. So it says a couple invests $7,000 in an account paying 3.4% compounded quarterly. Find the amount in the account after 5.5 years. Okay. So first let's identify all the information given to us. So our P, this is the amount invested. So we have P, this is equal to 7,000. Now we were given an interest rate. Your interest rate, you have to change the percentage into the decimal form. So 3.4% as a decimal, this would be 0.034. And then our N, so since it says compounded quarterly, this is the amount of times it's compounded in the year. So since it says compounded quarterly, our N is going to be equal to 4. It's compounded 4 times in the year. And then our time, since it says 5.5 years, let's go ahead and change that into 5.5 years. Now we plug it into our formula. So plugging it into our formula, we have A is equal to, well, our P is 7,000. And we have times 1 plus our R, which is 0.034, divided by N, which is 4. And we have raised to the N times T. So we have 4 times 5.5. Now it's all about simplifying. So we have A is equal to 7,000 times. So let me go ahead and divide 0.034 by 4. Okay, we get 1 plus 0.0085. We have raised to the 4 times 5.5 gives us 22. Okay, let's simplify a little bit more. So we have A is equal to 7,000 times, so 1 plus 0.0085, This gives us 1.0085. We have raised to the 22nd power. And now we just have to put this into our calculator. So we have a is equal to. So in your calculator, you're going to have to put this expression in first. So you have 1.0085 raised to the 22nd power. Okay, now we get an answer. Now you're going to leave that answer in your calculator. Then you're going to hit multiplication, put times, and then multiply it by 7,000. Okay, and now we get the amount after 5.5 years. So we get $8,432. And now whenever we're dealing with money, you round it to 2 decimal places. So we have $8,432.72. This is how much will be in the account after 5.5 years. Let's take a look at one more problem. So it says Jesse deposits $2,000 in an account paying 2.6% compounded semi-annually. Find the amount in the account after 3 years. Okay, so our P is the amount invested, which is 2,000. Our R is 2.6%. Let's change that into a decimal. So you have 0.026. Compounded semi-annually, which means it's going to be compounded 2 times in the year. So our N is equal to 2. And then our time is 3 years. So let's plug it in. So we have A is equal to, so we have 2,000 times 1 plus R, which is 0.026, divided by N. And then we have raised to the N times T, so N times 3. Now let's simplify it. So we have A is equal to 2,000 times. Okay, so the 0.026 divided by 2, that's going to give us 0.013. And we have raised to the 2 times 3, which is 6. Continue to simplify. We have 2,000 times 1.013 raised to the 6th power. And now we're going to go ahead and use our calculator. So let's put this expression first in our calculator. So we have 1.013 raised to the 6th power. Okay. Press enter, and now leave this result in your calculator. So you have 1.080579371. Leave that in your calculator. Don't round it, because then you might end up with some round off error. Now press times, and then put 2,000. So now we have $2,161, and let's round to 2 decimal places, so we get 16 cents. So the amount in the account is $2,161.16. So that was it for section 8.1. If you have any questions, just email me and I'll help you out.